Alright, so in this example, we want to compare values from different data sets. Okay, so it's often hard to compare values if they come from different data sets because you don't have the same group, the same mean and standard deviation. So this is a way of making a good comparison, right? So two swimmers, Angie and Beth, from two different teams, wanted to know how, find out who had the fastest time for the 50-meter freestyle when compared with their team. Which swimmer had the fastest when compared with their team, right? So here's the data. So for Angie, her swim time for the 50-meter freestyle was 26.2 seconds. Her team's mean time was 27.2, and the standard deviation was 0.8. Okay, so if I want to compare Angie with the rest of her team, we can see that their score is below the mean, below average, but you also need to take the standard deviation account because this gives you an idea of how spread out they are. Okay, the smaller the standard deviation, the closer the times are together. So you find the z-score. So you want to find the z-score for Angie. So the z-score is her time minus the mean of her team divided by the standard deviation. So her time is 26.2 minus the average team time divided by the standard deviation. So this gives me -1 divided by 0.8. So this is 1 divided by 0.8. This gives me -1.25. Alright, so this tells me that Angie is 1.25 standard deviations below the mean time for her team. Which means she's doing better. She's faster than average, and this is kind of a measure of how does she compare? How much faster is she? All right. Now let's look at Beth. So we want to find the z-score for Beth. So we have same x minus x power over s. So Beth's time is 27.3 minus the team time. She's also faster, right? The spread is a bit larger in her team, so divide by 1.4. So we have 27.3 minus 30.1 gives me -2.8 divided by 1.4, which is -2. So Beth is 2 standard deviation below the mean time for her team. Beth is 2 standard deviations below the mean time for her team. Alright, so basically from here you can conclude if I'm sort of comparing their time with their team members, Beth is doing better because she is further away from the mean than Angie is. Okay, but notice that we're not just subtracting the times for the mean because we're also taking into account what the spread of time is within the team. That gives us a better idea of how one particular person compares with the rest of the group. Okay, so because Beth is lower, Beth's z-score is lower than Angie's z-score, then Beth is doing better compared to her team than Angie is. Okay, so Beth's z-score is further away from the average for or her team. Compare to Angie's z-score. So Beth is doing better. Comparably. Alright, cool. So even though Angie's time is shorter, Beth is doing better compared with her team members than Angie is. Alright, cool.